been trying to do it right. I've been living a lonely life. I've been sleeping here instead. I've been sleeping in my bed. I've been sleeping in my bed.
Well, in this experiment we will put into practice concepts related to friction and forces. We will see how the coefficient of static friction changes depending on the materials or the masses of the objects used in the experiment. In this case we will use carton, and to get the coefficient of static friction we will use the critical angle method, which consists in finding the minimum angle so that the object starts to slide downwards in a plane. The formula that we will use to get the coefficient of static friction is coefficient of static friction is equal to the tangent of the angle. To prove this formula, we have that the coefficient of static force is equal to the force of static friction divided by the normal force. And the force of static friction is equal to the weight times the sin of the angle. The normal force is equal to the weight times the cosine of the angle. In this formula we cancel the weight in both sides, and we get that the coefficient of static friction is equal to sine of the angle over cosine of the angle, which is equal to tangent of the angle.
Hello, my name is Daniela Figueroa, and I'm going to explain the keywords or the key concepts that will allow us to understand better this experiment or this subject.
First, we will start with friction, which is the resistance to motion of one object moving relative to another. And friction force is a force that holds back the movement of a sliding object. Now we have the coefficient of kinetic friction. It is a value that shows the relationship between two objects and the normal reaction between the objects that are involved. We can also say that it is the proportion you get when you take the pulling force needed to keep an object moving and divide it by the force holding the two sliding surfaces together. It's also important to know what the coefficient of static friction is. It is the friction force between two objects when neither of the object is moving. The critical angle is the angle of incidence that provides an angle of rectification of 90 degrees. The normal force is the force that the ground or any surface pushes back upwards. And finally, we have the force of kinetic friction, which is the amount of force necessary to keep the two objects moving relative to each other. The force of kinetic friction acts in an opposite direction to the movement of the two objects.
Hi, my name is Gabriel, and I'm going to explain the materials and the variables. Well, for materials, we used a wooden plank, a protractor to measure the angles, and a cardboard. And for the variables, in the independent variable we have all materials used previously, and for the dependent we have all the angles and results that we obtained in the experiment.
Hi, my name is Nayibe, and I'm going to present our experiment and its process. So first, place the plane at the ground level and have the extreme A hinge, and make sure that the extreme A remains fixed, so the only extreme that can rotate is extreme B. Second, attach the assigned surface that your professor will assign, so in this case is cardboard and cardboard, and to the base of the container, and you can stick it with glue. Then place the first mass, that is 200 grams, inside the container, and put the container at the center of the extreme B. The next one is that very slowly raise the level of the extreme B so that the plane passes through the different angles. Later, at some point you will notice that the container starts to slide downwards and stop raising the plane at a point and record the angle with the protector for which this happens. So to this we call the critical angle. Then repeat this process 9 times more and record the critical angle for each repetition. Always make sure to raise the plane very slowly and continuously. Then calculate the average of the critical angle with these 10 repetitions. And finally, calculate
with this experiment are that the coefficients of frictions are different. Well, as we can see in this table, the average slide angle of the 0.2 kilogram mass object was 21.5 degrees, and using the formula for the coefficient of friction, we obtain that the coefficient of friction is 0.39, and in the 0.4 kilogram mass object, the angle was 26.3 degrees, and the coefficient of frictions we obtain 0.49. And finally, in the 0.6 kilogram mass object, the angle was 28.4 degrees, and the coefficient of friction we obtained was 0.54.
Finally, after make some observations and work with different kinds of angles, we can say or we can conclude that the variables of velocity and the variable of the time are directly affected by the other three variables in the experiment, such as the friction, the weight, and the inclination or angle. These three aspects affects the velocity and the time of an object, and talking about the movement of it. So our hypothesis was correct, and this is the final part of our project. Thanks.